Jai Hind. Myself, Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad, and this college is NBA accredited as well as NAC A++ accredited. So here in this particular video lecture, we are going to understand the concept for the amplitude modulation, and that has been taken from the Unit 5 as per the university syllabus of Abdul Kalam Technical University, Lucknow. So here we are going to see the concept for amplitude modulation. So what is modulation? Like, first of all, we should understand what is the modulation technique. These are the all waves, and as we can see, but get the feeling of the amplitude modulation is very important. So what is the feeling that, like, I'm talking to you in a very, so many mixed frequencies, but my voice is limited to this particular room. If I want to transmit my voice, obviously, I need some high frequency signal for transmitting my voice. But my voice is of just between the frequency range of 20 hertz to 20 kilohertz, as you all know. So this is a very less frequency which cannot be transmitted at all, and to the longer distances, obviously. So what should I do with my voice? What should I do the modification to my voice so that it can be transmitted to the longer distances, and the person sitting at the other end of the globe can listen to me? So that is how we are changing my voice frequency to that frequency which I can transmit at all. Whatever I'm saying, that is going to my audiences, that is going to you with some modulation technique, right? So what is that? So let us take any low frequency signal MT, which is modulating signal on which I'm going to perform my modulation, right? I have a very low frequency signal MT, and that is modulating signal. Here I have one signal MT. As you can see, this time period is very large, and if this time period is very large, the frequency is very low. So first of all, I will take a low frequency signal, modulating signal, in which I will say this is MT, right? Any low frequency signal which I want to convert it in a high frequency signal, right? So how to convert it? I will take one another very, very high frequency signal, and that I will call it as carrier signal. Okay. So if I see to this carrier time period, this time period is very, very small. This TC is very small and frequency is very large. Okay. For my voice communication to you through mobile, okay, it is in megahertz range, and my voice is only in hertz to some kilohertz range. So I need to convert from hertz to kilohertz range to megahertz range, that is 10 raised to the power 6 ranges. I need to convert more than that also. So here what I will do, I will take my modulating initial message signal, or I can say this is my message signal. Whatever message I want to give, I want to transmit, and I will take my carrier wave of very high frequency signal. Now I will modulate my carrier. Okay. Now have my words. I am going to modulate my carrier according to my message signal. Okay. Which parameter of the carrier wave is to be modified in accordance with my message signal? That is, here in this amplitude modulation case, I will take the parameter as amplitude. That means I will change the amplitude of my carrier wave in accordance with my message signal, and that is known as amplitude modulation. Okay, right? So this is how we are going to do the modulation thing, and specifically that is amplitude modulation, changing of my carrier's amplitude in accordance with the message signal amplitude, right? So here, see, I am taking this carrier wave of constant amplitude, right? Here I am taking it as, let's say, it is AC, and this highest is AM. So what I am going to do, I will change this AC according to my AM or message signal. Okay. So what I am going to do, I am going to transmit my carrier wave like this. Okay, this is my amplitude modulated wave which I am making. This is my amplitude modulated wave, right? This is my amplitude modulated wave actually. Instead of sending this, I am sending this red carrier wave. Okay, and here the carrier wave, which was originally, it was of constant magnitude, now it has, the magnitude has been changed according to my message signal, and my message signal got converted into some high frequency signal which now I can transmit, right? So here one more thing you must mention from the diagram, that is, this was up to AC, and this is my AM. So what is this? This will be AM plus AC. Now here, if I want to calculate this is my, the difference of these two, that AM is very small, AC minus, right? Okay. So what's that? This was my AC, and subtract this AM, and it will give you AC minus AM. So I have calculated this thing and the maximum amplitude of the carrier wave, right? Okay. Now since I am transmitting both the side bands, which I will explain you later about the side bands. So this is having the lower part as well as the upper part. So instead of transmitting only the carrier wave, I have modified the amplitude of the carrier wave in accordance to my message signal, and now I am going to transmit this modified carrier wave according to my amplitude of the message signal, right? Here I have taken this MT as a sinusoidal, normal sinusoidal function whose frequency is FM. This FM is very low. Okay, just for simplicity, I have taken the modulating signal as FM. Now this is FC, the frequency of the carrier wave, simple sinusoidal wave, cosine wave, obviously. So this frequency is very large. This is very low because this is my message signal. This is very large because I am producing, and I will change this carrier wave because I want the frequency to get into the range of my carrier wave. And now what is most important is that you need to learn this standard expression for the amplitude modulated wave, and I will suggest you all to remember this so that you can successfully do the numericals for amplitude modulation topic. Okay, so it is AC, some carrier wave plus the multiplication of carrier wave to the modulating signal, right? So this expression you need to learn, that is AC plus AM cos 2 pi FMT whole bracket cos 2 pi FCT, right? Now, just take this AC to be common, and you will left with 1 plus AM by AC cos 2 pi FMT cos 2 pi FCT. This AM by AC, is known as modulation index, right? This AM by AC is nothing but the modulation index or modulating factor. Okay, and this is represented by this mu. Mu is equal to AM by AC You should have no doubt for this. Modulation index is equal to magnitude of the modulating signal, maximum amplitude of the modulating signal, and the amplitude, maximum amplitude of the carrier wave. So this mu is equal to AM by AC, and how this mu plays a very important role that we will see in the next slide. So already I told you, if I calculate this thing, see here, if I calculate this thing, this is my AM plus AC. So what is the maximum amplitude of the AM modulated wave? This is AM plus AC. This I have calculated, that is AC minus AM. Okay, this is my minimum amplitude. This is my maximum, this is my minimum. Just remember, and we are going to the next thing. So A max is AC plus AM and A min is AC minus AM. Okay, so that we have already calculated the maximum amplitude of the amplitude modulated wave and the minimum amplitude of the amplitude modulated wave we have already understood in the first slide. So now I can calculate AC in terms of A max and A min. I can calculate AM in terms of A max and A min, right? Now here this AM is equal to A max minus A min by 2, and AC is equal to A max plus A min by 2. How I calculated? Just two variables and two equations method. Once you need to, when you will add it, you will get the AC. When you will subtract it, you will get the AM, right? So by this, you can have the ratio of AM by AC. That is, AM by AC is nothing but the modulation index, and you can get this particular expression after solving. The mu is equal to A max minus A min and upon A max plus A min. So this is also important for solving the numericals for modulation, amplitude modulation problems, right? Next. Now we are going to understand the role of modulation index in the amplitude modulated systems. Okay, so we have understood the two formulae. First is mu is equal to AM by AC. If AM is less than AC, if AM is less than AC, then there will be a gap. See, in the first slide itself, if AM is greater than, less than AC, see, if AM is less than AC, then there will be a gap. If AM is greater than AC, then it will cross this x-axis and will go down the x-axis, right? So there will be a overlapping, and if AM is exactly equal to AC, this line will touch like this. Okay. So here are the three cases. If mu value, that is between 0 and 1. 0 and 1 means AM is less than AC. If AM is less than AC, there will be a gap. If mu is exactly equal to 1, these two will touch each other. Okay. And if AM is greater than AC, this AM will go down the x-axis, and this is not preferred. This is okay, but this is the preferred modulation index for amplitude modulation process, right? Again, we are going to the expression which we already learned, that how the expression have been written. I told you to learn this expression, this standard expression for AM. My suggestion is you should learn this equation, because everything you will get from here only. Okay, so just open it and we will find this term, this two terms, this AC into cos 2 pi FCT plus mu AC into cos 2 pi FCT into cos 2 pi FMT. Now here we can apply the formula for cos A into cos B, which is what? 1 by 2 cos A plus B and plus 1 by 2 cos A minus B. So this is how we proceed for cos A into cos B. What we have done is the same thing. This AC mu by 2, AC cos 2 by FCT same, and this is cos A cos B. We have applied the formula in this way. Okay. Now, this is the standard expression for AM. What we have done is we have opened this standard expression according to the cos A into cos AB, cos B formula, right? So we have got three frequency component. First frequency component of FC, second frequency component for FC plus FM, and third frequency component of FC minus FM. So this FC is the frequency of carrier wave. Already we have seen. And FC plus FM is USB, upper side band. FC minus FM is LSB, the lower side band, right? So the amplitude modulated wave has three frequency components, one for carrier, one for upper side band, and third is for lower side band. Just remember, always remember, these are the three frequency component, and here I would like to make it that this is my LSB, this is my USB, and this is FC plus FM. This is minus FC minus FM. This is minus of FC minus FM. And this is minus of FC plus FM. This is minus FC and this is plus FC. And the band gap is 2 FM. The band gap is twice of FM, what we have written here. So this is the band gap which has been written here, that is twice FM. So remember, the band gap of the amplitude modulated wave is twice of FM. Now coming to the power calculations. I have modulated my carrier wave in accordance to the amplitude of my message signal. Now I want to calculate the power contained in the amplitude modulated wave. The total power is being the power of the carrier wave, power of the USB upper side band, and power of LSB, right? If I want to calculate the power, then a simple carrier wave power I can calculate, that is AC by root 2, the VRMS value of this AC by root 2 upon R. So that will be what? VRMS square upon R. So here the RMS is AC by root 2. So what will be my power is AC square upon 2R. AC upon root 2 square upon R. Similarly, I have calculated this AC mu by 2 upon root 2 square upon R. This is power of carrier wave. This is the power of LSB, and same is the power of USB. That means power of LSB is equal to power of USB. Why? Because both have the same amplitude, AC mu by 2. So powers will be same because everything is dependent on the power, the amplitude of the wave. So power of LSB is AC square mu square upon 8R. And if I simplify this and add all the carrier power, the power of LSB, the power of USB. So this PC, this PUSB, this PLSB, I can solve the total power in terms of the carrier power. And this expression, again you need to learn. This is very important expression for amplitude modulated wave. Okay, if mu is equal to 1, then obviously we are sending the 3 by 2 times power of the carrier as a total power. So it is very important equation as far as the amplitude modulation is concerned. Now coming to the numerical of the amplitude modulation, we will solve one numerical based on this. The AM transmitter has a carrier power of 30 watts. What it is given? The PC is given. PC is equal to 30 watts. The percentage of modulation is 85%. That means mu should lie between 0 to 1. So I will write it, instead of writing 85, I will write it 0.85, because I know that mu is what? Mu is between 0 to 1. So I will take mu is equal to 0.85. So here it is. Calculate the total power. So total power I can calculate by just using PT is equal to PC into 1 plus mu square by 2. Okay. So I will calculate. Okay. So put the values and you can get the answer. The next question has been asked in the numerical is calculate the power of USB and the power of LSB. So here power of USB and power of LSB, that means the total power I have, the carrier power I have, whatever power is being left, that will be divided between USB and LSB, and the same has been done. The total power I have, the I've calculated 40.8. So 40.8 minus 30 is the power both in USB and LSB. And LSB power is same as USB power. So I will divide it by 2 to find out the power of one sideband. Whether it is, and if you want to use the formula, you can use the formula also, that already we have seen this power of, this AC mu square upon 8R, or see this AC mu square you can directly apply the formula to, and this AC square upon 2R is PC. Okay. So AC square upon 2R is your PC. This. So you can calculate is mu square by 4 into PC. You write this and you will get the same answer. Okay. So in both ways you can solve the numerical. You want to apply the formula of power sideband, then you can apply that also, or you want to use the concept that whatever power has been left from the total power, that will be divided between USB and LSB, and you can solve the numericals very easily. So there, these were all the concepts with the amplitude modulation. Thank you.